Hey guys, thanks for coming back again. If you have subscribed, if you are yet to subscribe, just click on the subscribe button and also on the bell beside it. That will definitely notify you when we drop a new video. In this video, we want to talk about the salt analysis for the WAEC 2021 chemistry practical. Excuse me, let's get something. So as I was saying, in this video, we're going to talk about the salt analysis for the WAEC 20 in preparation for the WAEC 2021. And moreover, we are being familiar with analyzing salts, that is detecting the cations and the anion present in the salts. And at the same time, we should be also familiar with identification of gases. So, and these are the basic schemes for salt analysis. And then when in some cases where we have to mix two salts together and try to analyze them, in such case, we should be expecting that one of the salts should be insoluble and one of the salts should be soluble, so that at the end of the day, we'll be able to mix them and dissolve them in water, so that the soluble one will go along with the filtrate and the insoluble one will be the residue. So then we can analyze separately. But in this case, when we have two soluble salts, how is such going to be possible? So we are going to be working with NH4, 2, CO3, and then copper sulfate. These two salts are soluble in water, and moreover, copper sulfate has a characteristic color of white button, when the hydrated one is always in blue color, while this is white color, and both are soluble in water. So how does this analysis works in terms of separating the two and then analyzing separately which one will be the solute, the filtrate, and which one will be the residue? So in this case, that is what makes this two salt mixture a different one. What actually happens is that when these two salts are mixed together, there is a reaction called double decomposition reaction which takes place. And this double decomposition reaction is a method of preparing insoluble salts. So which means when these two salts mix, both are soluble in water, but at the end of the day, we are going to create two more salts different from this. That means there will be exchange of anions and cations within the salt, and then there will be formation of one soluble salt and one insoluble salt. So if I am to write the equation of this reaction now, I'm going to have NH or 2 CO3 plus CuSO4, and that will give me the formation of this going with this and also this going with this. So I'm going to have NH4 2SO4. Then I'm going to have CuCO3. CO3 is characterized by a green color, and moreover, this has a characteristic blue color. So once you mix the two together, you will see a change in color to a characteristic green color, so which indicates the formation of this. And moreover, this is soluble and this is insoluble when they mix with water. So which means that we are going to have these as our filtrate and these as our residue. As we proceed with the experiment, then we begin to analyze for our cations and anion. So we have the materials needed here. We have the two salts here. This is CuSO4. As you can see, it has a blue color here. So then we have the NH4CO3, and this actually I'm not supposed to open for a long time, so it has a characteristic white color. So now we have all the necessary materials here to perform the experiment. So let's see how the experiment goes according to the steps given to us here. We said C is a mixture of two inorganic salts. Carry out the following test on C. So firstly, we have to mix the two salts together here, and that is, as you can see, we are having traces of green color and a deep blue mixture here. So and that is the mixture of the two salts. So we are expecting the reaction should have taken place here. So and then thereafter we go through the steps on the board. So now the mixture is here. We have the mixture already, the 2 salts. So then let us go through the process or the procedures that we have on the board there. So this is the source that will be given to you to perform the experiment. So now let's run through the experiment and see how it goes. So following the step as I read, we go through it one after the other. So the first step says C is a mixture of 2 inorganic salts. That's an information given to you. Carry out the following test on C. So put all C in a beaker. So this is a beaker here. So we are putting all C into it. In the absence of spatula, I'm using this. So put all C into the beaker. So this is all C in the beaker. So C is now in the beaker. Now we have C in the beaker. So we are meant to add 20 centimeter cube of water. It's not necessary you measure the 20 centimeter cube of water, but you can just add the water to a level of which is going to dissolve it. So then our observation is that we have a deep blue solution formed, and there is evolution of gas, and that's definitely, if you perceive that will be ammonia gas. So we are putting that into solution. We should be able to identify this gas evolved. That is the 2 salts. Then we have to filter. We have to filter the mixture. Now let's filter the mixture and see how it goes. These are filtrating apparatus. So let's filter the mixture. We give it some little time for filtration to occur. So after the filtration, we have the residue here, and this is the residue, and then this is the filtrates. We have the filtrate, which is a blue solution. So we are meant to perform some exercise on the residue and at the same time on the filtrate. So on the residue, we are meant to put the residue in a boiling tube. So we are going to put this residue in a boiling tube, and this is a boiling tube. So let's put the residue into the boiling tube, and the boiling tube can be held. You can hold the boiling tube using your test tube holder. So now we have put that into the boiling tube. Let's put the residue into the boiling tube. We are working with the residue right now. So actually it should be spatula used for this, but I don't know where I kept the others. But not on the examination day, actually we're gonna get them. So I have put that into the boiling tube as the instruction is given. So now the next thing is we go through the second step of the question, which says to the residue add dilute HCl. So let us add dilute HCl to this, and this is HCl. And moreover, when you are asked to add it, you have to add in drop, then you add in excess. So now I'm taking that with a dropper, so I'm adding dilute HCl to this. So look at it, the response. This is in drop.
Actually, I'm having a kind of blue solution here. Then I'm having a kind of deep blue solution formed. Actually, a little effervescence occurs. Then I have a deep blue solution. Can you see that? So that is when HCl is added. Then what will be your inference in this perspective? So effervescence occur, then we should be expecting that colorless, odorless gas, which turns lime water milky, is evolved, and that is on the addition of HCl. So then what do we suspect? We suspect that CO3 2 minus is present. That should be our inference. CO3 2 minus is present. So and then actually this is just too much. The residue I put here is just too much. So you can actually reduce the quantity you're putting. So to ensure that you have accurate results and make it visible. So now the next step now says divide the resulting solution into two. So which means the solution, I'm dividing it into two. So the first portion is what I'm adding here into the test tube. So I'm adding the first portion here. So this is the first portion. Let me reduce that. Okay, this is enough. Then I have the second portion. The second portion. So let me keep this. So now these are the two portions of the resulting solution. So let's perform the exercise on one of them. So the one says to the first portion add NaOH. So let me rinse this so that I can add my NaOH. So now this is NaOH, and I've always advised you add in drop first. Then later you add in excess. In drop, you can see a gelatinous precipitate which is color blue, light blue precipitate forming. So let's add it in excess and see what will happen. So which means the blue gelatinous precipitate persists on addition of HCl to the residue. Sorry, NaOH to the initial mixture of residue and HCl. So this blue PPT formed persists. So that means we are suspecting copper. So in this sense, copper is suspected. So NaOH is just used to suspect copper ion in solution, and that is why we are suspecting copper since the blue gelatinous precipitate persists. So and that is for this. So to confirm copper, we have to take the second portion. We have to take the second portion and then add ammonia to it. So this is ammonia solution. So to the second portion, I'm going to add ammonia. So on this addition of ammonia in drop, look at the response. I'm having a light blue precipitate in drop. So let's put that in excess and see what will happen. So the light blue precipitate persists, as you can see. And it appears somehow deep in excess too. It appears deeper in excess. So this confirms copper ion. So which means we can go to the inference and write the light blue to the observation and write light blue precipitate formed in drop and deep in excess. So which means copper is being confirmed here. So and that is confirmation of copper. So now let's move on to the step. So we have to the second portion add aqueous ammonia. So which we have just done in drop and then in excess, and we are given that inference and observation. So now let's go for the next step, which is divide the filtrate into two portions. So we are going to work on the filtrate now. we are dividing the filtrate. This is just too much, but we are going to divide it into two portions in the test tube. So this is the first portion of the filtrate. That is too much. So this is the first portion. And then we have the second portion. Let us have the second portion. Okay. Now the second portion of the filtrate. So both are placed. So now the step now says, to the first portion in the test tube, add dilute barium chloride. Add dilute barium chloride. So this is barium chloride, and we are adding that, and I told you, in drop and then in excess. So on addition of dilute barium chloride, what do we have in drop? We have white precipitates. As you can see, we have a white PPT formed. So that is in drop, and then in excess, what happens? The white precipitate persists and it appears more thicker. So, and in this case, you suspect SO4 2 minus and then SO3 2 minus. So the inference is going to be SO3 2 minus, SO4 2 minus present. So that is for the BaCl2. But to confirm either of the two, we are going to add HCl, dilute HCl. So if the precipitate dissolves, it shows that SO3 2 minus is present. But if the precipitate do not dissolve in HCl, which means SO4 2 minus is present. So now let's move on. So this is HCl, and then so we had that in drop. Precipitate still persists in drop. So let's add in excess. Precipitate still persists in excess. So which indicate that SO4 2 minus is confirmed present in the filtrate. So that should be in our second observation table test and then inference. So I'm going to show you the table at the end of the experiment, don't worry. So now let's move on to the second portion of the filtrate. So to the second portion of the filtrate, we are told to add dilute NaOH and then warm. So when we add dilute NaOH to this, then we warm it up. So let's move ahead. This is dilute. Let's put it in drop. Wow, we have a blue gelatinous precipitate in drop. So in excess, the blue gelatinous precipitate formed and is more thicker in excess. So that should be your observation. Then let's go and warm it up to see what will happen when warm. So warm it up, I have to light up the buzzing burner. Actually, this is not well set because I'm going to make it look this way. I would have gotten a matches, that would be quite better. But okay, I think I've lightened it up to this extent. So then it's needed to be controlled. Here, then I heat. Okay, as I'm warming, I'm perceiving a gas here, and I suspect ammonia gas, and this gas will turn red litmus paper blue, damp red litmus paper blue. Wow, that's ammonia gas. So when you put damp red litmus paper, it turns it blue, and at the end of the day, ammonia will be confirmed. Okay, and it has a choking smell. The gas do have a choking smell. It can turn damp red litmus paper blue, so ammonia gas is confirmed here. Then what will be your inference? The inference is that ammonia gas is evolved from NH4, so which means in the filtrate, NH4 ion is also confirmed. So that is the end of the test we are meant to perform on C. So now let's look at how the table is going to be like after the experiment.
So, with all our observation and inference with the test, everything has been summarized in this table. Like the first step we performed with C and water, we have a deep blue solution with green PPT. So, and then that is what we can see there. The precipitate is green, just like I told you. This, which happens to now be the residue. So then we filter that. We have a deep blue filtrate. Can you see? Actually, this is not actually deep blue, but we have a blue filtrate. This is not deep due to the part of some factors. So and then light green residue, just like I've said, we have a light green residue here. So and then let's move on. Residue plus HCl, which we performed the other time, we have effervescent occur, a gas having colorless, odorless gas. And you know, in each case of observation, we have our inferences. So, and the first inference is C is a mixture of soluble and insoluble salt, because since one can go out as a filtrate and the other one as a residue, which means we have two insoluble salts, which I've explained the reason why it is two insoluble salts from the beginning of this video. So we have a kind of double decomposition reaction because the two salts even are soluble salts rather. So, but in the mixing of the two salts, we have production of soluble and insoluble salt. So then the next one says residue plus effervescent occur, we suspect CO2 gas from CO3 2 minus. When we added HCl, there is a blue PPT formed. Hereafter, we have residue plus HCl plus NaOH. Same time, I think we added NaOH, and since everything occurs at the same time, so we confirm Cu2 plus. When we added NaOH, we have blue precipitate formed and persist in excess, so we confirm Cu. Then, we suspect Cu. So then, to confirm Cu, we added NH3 to the second portion, and we have light blue precipitate formed in drop and D in excess. So then, Cu2 plus is confirmed. Then to the filtrates, as we did it, we added filtrate plus BaCl2, we have white PPT formed, and we suspected SO4 2 minus and SO3 2 minus. So then later we added dilute HCl to the initial mixture, then we have white PPT insoluble. So once insoluble, this will be confirmed, SO4 2 minus, tetrasulfate 6 ion. So then thereafter we have filtrate plus sodium hydroxide. Then we have, though I didn't actually write what we observed, I think we have a blue gelatinous precipitate. So permit me to do this. We have a blue gelatinous precipitate. We have blue gelatinous PPT. So then on warming, a gas is evolved. And the gas evolved turns red litmus paper, damp red litmus paper blue. Damp red litmus blue with choking smell. So this gas indicates that the gas is ammonia and it is from ammonium ion. So in this case, we are done with the experiment. Thanks for watching. Please subscribe to our YouTube channel. It's free. Thank you.